Every time a developer hears "don't repeat yourself," the same thing happens. They start deleting duplicated code. If two functions look alike, gone. A couple of if statements extracted into helpers. And for a while, it seems to work, it seems clever. However, after a few weeks, it becomes a problem. No one knows what those helpers actually do. And while you might call it dry, don't repeat yourself, in the reality, it's just harder to understand. The original definition of dry comes from the book The Pragmatic Programmer. And there you can read that every piece of knowledge must have a single, unambiguous, authoritative representation within a system. Pay attention. Can you find the word code? Can you find the word function, class, method? Anything that resembles just code? No, you can see it. So let's dig deeper. Let's go to the new edition of the same book. On the new edition, the authors added this paragraph where it says that dry is about the duplication of knowledge, of intent. It's about expressing the same thing in two different places, possibly in two totally different ways. More interesting than this paragraph is if you go to the previous ones, and you will find that they are basically saying that they have done a poor job on the previous edition, on the original edition, because no one understood what "don't repeat yourself" actually means. They wanted to make it clear that it's nothing related to just don't copy paste lines of source code. It's something more than that. It's that, but that is just a tiny part of it. And the key word here is knowledge. And what is knowledge? Knowledge can be expressed in several different ways. It can be code, it can be documentation, it can be business rules, it can be the data model, it can be comments, it can be many different things. And in a typical solution, in a typical application, in a typical enterprise, knowledge will live in different places. And often, we'll find the same information being spread in different sources. For example, in this case, we might have this tax definition, the definition how we calculate that tax, and we might have it in source code, it might have it in the documentation, business rules, wherever. And what if we update one of them and we go to the source code because it's the one that will produce something that will change for our users? We update that one and we simply forget to update the other ones. Now we have inconsistency. And one thing we know is that when knowledge lives in different places, now you need to maintain, you need to evolve all of them together. If you forget to update one of them, now things start to drift, and now you start seeing those conflicts, those misexplanations, those things that don't make sense. And here is where the mess begins. So the real question isn't about, am I duplicating lines of code? The real question is, am I duplicating knowledge? And once you start looking into things in this way, you start seeing the problem that you have in hands. You start seeing that it's so much more than having two lines of code that look alike. And here is where the things start to get ugly. Because not only your system is getting bigger, also is contradicting himself. So let's talk about why it matters. Knowledge in software is never static. It doesn't happen to create something and it will stay that way forever. Why? Because the rules keep evolving, and also other rules will come in. Requirements will keep changing, will keep shaping the nature of that software. Eventually, a given feature might be impacted by the other ones living around. So if any type of these changes, if any of those evolutions can build new knowledge, and on those moments you duplicate that knowledge, now you have even more places where you need to maintain it, even more places where you need to touch when you need to update that knowledge. And it would be fine if that knowledge just stayed there, quiet. The problem is that it will evolve, but it will evolve at different paces. You might change today the implementation of a given feature. 1 week later, someone realizes that the documentation is not correct. It might adjust it, or you might ignore it. You might realize that there's a given comment somewhere in the test that is referencing the way that the system used to work. So those things take time, or they might go unnoticed, and they create friction. That's the problem that we are fighting. And obviously, being developers as we are, we know the risk of copying and pasting source code. We have the implementation of a given rule, we duplicate that code, now we have two implementations of the same rule. There's the risk that we'll evolve one of them and the other one will stop there, will stay quiet. And now we have a problem. Okay, we have two different versions of the same thing. So now what do we do, right? This is a source of a lot of problems. So that's why we tend to go after this type of duplication to implement the dry. For example, if you have something as simple like this, okay, you have the order status and you are checking if it's in a given status before processing the payment. Now you need to get the orders from the database and you want to check it by status. You see the pending payment, you duplicate that, copy and paste. Okay, you use the same key. Seems fine, but it's not, because you duplicated a simple string, a simple piece of text, just a small line of code, and now you have a problem. The day that I'm reviewing, for example, the names or the codes of different status, now I have a problem. I need to update it in different places. If I forget to update one of them, there's a problem. That's why we tend to move it to a different place. We try to avoid it to avoid that duplication, to remove that risk. And this is the reason why dry exists. The reason is not to avoid a few lines of source code, is not to have fewer lines of code, is not to feel clever. The reason is that next time that you need to change your source code, next time that you need to evolve a given feature, you don't need to do that mental effort of trying to understand if there's the risk that something else also needs to be updated. The goal is that you feel safe and you know what you are doing. Okay? You know that there's nothing else that needs to change for that feature. So if dry is about avoiding the duplication of knowledge, how do we apply that in practice? How does that affect my source code? So let's see some examples of good practices of using the dry principle. So let's make this practical. Here's what good dry actually is. Imagine that you are validating an email in a couple of places. By the way, don't do the validation this way. This is just a demo. So you have the validation in different places, in different methods, in different functions of your code. They might live in the same file, it might be in different files. It doesn't matter. But the validation is basically the same. The logic of validating the email is the same. And we have it, for example, in this case, to create a new user, also to send an invite to the newsletter as well. So what we have here is multiple places with the same logic. It's not only the fact that they have the same line, in fact, it's the same knowledge, the knowledge of how do we validate an email. So we can move that knowledge to a different place, create that deduplication in order to start using it when we need. We created a new artifact that is this valid email function or method that is responsible to encapsulate that knowledge. Now there's a single source of truth for that knowledge, for that rule, and we can start using it in the other places. So we avoid all of those risks that you have seen before. So let's see another example. Imagine that we zoom out and we start seeing this from a different level. And we have our order service, the invoice service, the checkout service, and then we start seeing that we have the same logic to calculate the tax in all of them. So, same knowledge, same business rule, 3 different places. What will happen if tomorrow we need to update that tax? If it goes to 21%, there's a huge risk that we will forget to update one of them. However, we can apply the same idea and create a new source of truth, a new keeper of that rule, a new keeper of that knowledge. So we can create a class that will be responsible to calculate and apply that tax. And that's what dry is about. It's not about shaving some lines of your source code. It's not about trying to do more with less. It's about assigning a proper home to every piece of important knowledge that you have in your system. Of course, there's a catch. There's always a catch, you know it. And for some reason, the dry principle is named dry principle, not the dry rule, not the dry do it every single time. It's a principle, it's a way of approaching the problems, is a rule of thumb, let's say. It's not something that you apply every single time. Why? Because of all the trade-offs involved. Let's take a look on them. One of the trade-offs is indirection. You can see one line of code that will be calling an helper that calls another helper that then calls a class. So if you want to understand a single thing, you need to go to multiple places to have a clear picture of what is happening. The other one is an abstraction overhead. In order to make a piece of code generic enough to be used in different places or even replaced, you need to come up with things like interfaces, like configurations, all of those things, often just because of a small block of code that could be quite simple. So you need to create a whole system to manage this new abstraction. And now we have coupling. Why? Because if you extract the logic, the knowledge to a given place, and everyone needs that logic, everyone will depend on him. So, if one day you need to evolve, you need to change, there's an impact on all of those consumers, or everyone that is depending on that class, on that method, on that function. So, there's no doubt that dry will help you to avoid the duplication of knowledge. However, there's some drawbacks, okay? There's some risks as we have seen. And one of the problems is that often there's a kind of a premature optimization trying to avoid all of these type of problems that might happen in the future that now are creating a cost for an eventual future that you don't know if it will ever come. At that point, dry can create more problems than the ones that you had before. And that's exactly what happens in many projects where dry is not correctly applied. So let's take a look on the things that you need to pay attention. Our goal with dry is obviously to make things simpler, not things worse. There are some common problems that we start seeing when applying dry. One of them is going right away to come up with abstractions, with interfaces, with things that will avoid having that duplication. That's why we often hear about things like the wet, that means write everything twice. Or for example, the rule of three, that says you need to see the same thing at least 3 times before being concerned with moving that thing to a different place. Those approaches are basically reminders that we often go too soon to the approach of trying to remove the duplication. Okay, often we don't have enough information to understand that yet. Also, it's quite common to see developers trying to force things that look similar to be the same. For example, imagine that you have logic to validate a customer and also logic to validate a supplier. And you can see that there are some things in common. So you try to create some type of abstraction, some type of logic that can apply to both of them, at least for the things that are in common. So you merge them. However, in fact, they are not the same knowledge. And this will create more problems than the ones that are addressing. Because now there's the risk of evolving for one of the knowledge cases, but having an impact on the other one because the same rule shouldn't apply on the other one. And now the complexity of maintaining that common source code becomes a problem, becomes harder. The cognitive load is quite high. And the worst of all is mistaking duplicated code by duplicated logic, duplicated knowledge. What does that mean? For example, in this case, we have 2 different methods. One of them has the logic, the decision, the rule, the knowledge to understand if a user can receive an upgrade. And the other one, if it can get a discount. And when you look into the source code, in fact, it's the same. Looks like a copy-paste, and we change the name. However, I can't say it's the same knowledge. Why? Because there's the risk that at a given point, someone will come here and change one of them. So when I change, for example, the logic for the discount, and no longer it's the 30 days, now it's 20 days, for example, for that case to exclude it, and the monthly spent went from 100 to 50, now I have a problem. Because by changing One of them is I took the decision of trying to create a single abstraction would impact both of them. By having both of them in two different methods, now I can evolve them without impacting each other. And I know that this feels tricky, okay? It looks like something hard to know beforehand that might happen or not. So let's talk about my rule of thumb. So try is a principle. It's something that you can use and you need to take the decision based on trade-offs. But I have a rule of thumb for these scenarios where I can see two lines of code that are the same, they look like copy-paste. Should I merge them into a single place or not? I like to use the rule, if it changes together, it stays together. What does that mean? If those two lines of code, every single time that I need to change one of them, I will need to change the other one, it means they are the same. So they stay together. However, if for some reason there's the risk that I can evolve one of them and the other one I will not, that means that they stay apart. Example, imagine that you have the logic, for example, to get all the existing transactions of your website. And that logic is being used either on the management part of your portal and in the consumer part as well. That logic might be exactly the same, but by the simple fact that one of them has the purpose of serving the portal and the other one is under the management tab of that portal, it might lead that I need to change one of them and the other one stays the same, because I might have a new requirement that is specific for administrators. So there's nothing wrong on having two duplicated lines of code as far as they are not the same knowledge. If it changes together, it stays together. The important part is that you treat dry as a principle, not as a rule. If you start applying it every single time, like if it was a rule, eventually it will backfire. So from now on, instead of obsessing about duplication of lines of code, start obsessing about duplication of knowledge. Okay, that's the idea of dry. That's the idea of the dry principle. So there's mainly three things important for you as a developer. Don't abstract too early. While you are still learning about the problem, it's still fine to have that duplication. Always look for duplication of knowledge instead of duplication of syntax. And remember, if it changes together, it stays together. And if you want to see where dry can go really wrong, watch this video next, where I show you the risk that it imposes to testing. And now I'm curious, where have you seen dry being applied in the wrong way more often? Was it in business logic, in tests, or other thing? Drop a comment below, I would love to hear your stories.